Okay, so to finish off this question, there's actually a lot to write for this question. I should probably zoom out here, try to fit as much as I can. So I'm going to probably end up writing a bunch on the left-hand side and then have more room on the right-hand side, just so you know if you wanted to continue. If you have really small writing, you might be able to fit it all in just from top to bottom. Okay, let's see what I can do with this. So again, we had part of it started for you. So just to write down here, we ended up with getting the derivative y prime equal to the derivative of the outside first, so bringing the 3 in front, x plus 2 over x squared plus 5 to the exponent of 2, and then multiplied by taking the derivative of the quotient of the inside, which would be the derivative of the numerator, which is just 1, multiplied by the denominator. So I'm just going to get rid of the 1 this time, minus the derivative of the bottom, which is 2x multiplied by x plus 2, all over the denominator squared. And then we were saying, what would you do from here? So the first term here, I would just copy down again. So the 3 bracket x plus 2 as the numerator, x squared plus 5 as the denominator, and they're both squared, right? But can I do anything with the top? Again, I had the 1 there, so I could expand, but I'm expanding the negative 2x really into the second bracket there. So that would be multiplied, right, by x squared plus 5 minus 2x squared minus 4x. And then just leave the denominator the way it is. And then can I collect any like terms? Does that help me out at all? So again, the first term here, I would just copy down again. Sorry, forgetting I got to squish this in here, right? X plus 2 divided by x squared plus 5 squared, x squared minus 2x squared. So 1 take away 2 would end up being negative x squared minus 4x plus 5. Putting it in the proper order of terms over the denominator. Now, if we look at our previous examples on our page 1 there, after we've expanded and gotten as far as we could, I actually took a look to see if I could factor. So if I was going to factor this numerator, the first thing I would probably do is factor out the negative to take a look and see if I can do simple trinomial factoring, right? So again, I'm just copying out the first term. Multiplied by, I factor out whether you want to write a 1 or just factor out the negative, I'd be left with x squared plus 4x minus 5. Again, all the terms just, their signs change. If it was negative, it's positive, negative, positive, positive turns negative. So can I factor that trinomial? Copying out the bottom here. So x squared plus 4x minus 5. Are there two numbers that multiply to the last, multiply to the end, negative 5, and add to the middle, 4? And I just won't worry about the negative. I'll just keep it outside of the brackets once I've factored. So to multiply to 5 is just basically 1 times 5. In order to get a positive 4, the bigger number could be positive. So therefore, I can break that down. And also here too, if I'm going to start rewriting this here, with more brackets, this squared, just change the color here, this squared is placed on both the x plus 2 and the x squared plus 5. So I could break that down as x plus 2 squared, and that would be like 3 over 1, right? Divided by x squared plus 5 squared, multiplied by negative, and again, x minus 1 or x plus 5 can come first. It doesn't matter the order, right? All over x squared plus 5 squared. I don't know if I'm even going to fit this all on this page. Yeah, I can't fit anything else below here. So moving back up top to continue on, what can I do here? So I'm taking a look. I have a negative 1, which is a constant, and the 3. So -1 times 3, I could just change that to a -3. And then I have all my brackets multiplied by each other. So I have x plus 2 squared. And then I can write down, I'm just going to do it out of order on purpose, x plus 5 and x minus 1, just to show that it doesn't matter what the order of these are, right, when they're being multiplied together. And then if we look at the denominators here, if I'm multiplying, right, the two denominators together, the x squared plus 5 is common, right? So this is my base. So when I have bases that are the same and I'm multiplying, what do I do? The exponents is I add them. So that actually turns into a nice x squared plus 5 just to the power of 4 now. Now, there's nothing I can cancel here, right? That's x plus 5, that's x squared plus 5. I'm thinking that's as far as I can go. But if we go back up to the original question here where it said the tangent line is horizontal. So we said if the tangent line is horizontal, then the slope is 0. And if the slope is 0, then the derivative is also 0, right? So if this is my derivative, y prime, I want to make it equal to 0 in order to figure out the points on the curve where that tangent line is horizontal. So if I set it equal to 0, if I was to cross multiply, I'd put that over 1. Let's say I was to cross multiply. I'd end up with 0 times x squared plus 5 to the power of 4. So 0 equaling that times 1. So I would end up with just the numerator because of that 0. So this would be my next line. I've gotten rid of my denominator by multiplying it by 0, right? Now I can just set each of these brackets equaling to 0 to figure out what my x values are. So I have x plus 2, set that equal to 0. I have x plus 5, setting that equal to 0. And I have x minus 1, setting that equal to 0. So what are the values of x's? So here, x plus 2 equals 0, bring the plus 2 over, 0 minus 2, x is going to be equal to -2. X is going to be equal to -5, and x is going to be equal to +1. So -2, -5, and +1. Now it says determine the points on the curve. Those are just the x values. So now I need to find my y. So just point out here, I need to find my y values. Also, right, because I only have the x values of the points. So I go back to my original, right? Always, ever since grade 9, we always plug in back into the original. So if I have y here equaling x plus 2 over x squared plus 5 squared, and I want to evaluate where x equals -2. So if we just work with this here, because I don't have room to like plug everything in step by step, -2 plus 2 would just be 0. 0 squared is 0. 0 divided by anything would be 0. So technically it would be 0 divided by 9, right? Oh, sorry, that's a cube too, not a square. I'm just noticing that now. So that's fine, we can change. For that question, I didn't change anything, but still, for the other ones, it might. So I'd have 0 divided by 9 cubed. So my answer for y is going to end up being 0. So therefore, that's 1 point. -2 first and 0 is 1 point along this curve where the tangent line is horizontal and where the slope is horizontal. So here's my original equation again. So I could write it out again. And now I want to evaluate where x is equal to -5 next, right? So then I would have -5 plus 2 would be -3, right, cubed. So my numerator would be -3. -5 squared first would be 25 plus 5 would be 30. And then I'd want to cube that. But I could get that down to lowest terms first. I can divide by 3 and divide by 3 and get -1/10 cubed, just because then I have smaller numbers to cube, right? -1 times -1 times -1 is still going to be a -1. And when I have 10 to the power of 3, it's just 3 zeros. So I end up with -1 over 1,000. So that is my point. I would like to fit it in here, but I don't think I will. Therefore, a second point would be -5 on x and -1 over 1,000 for y. It's my second point. I'm just trying to squeeze this in here, guys. And then for my last point, I have x equaling 1. I would have 1 plus 2 is 3. 1 squared is just 1 plus 5 be 6 cubed. But again, why not break that down into 1/2 lowest terms? If I were to cube 1, I'd get 1. 2 times 2 is 4 times 2 is 8. So I'd end up with 1/8. So therefore, my third point would be 1 and 1/8. And then I would put an official therefore statement at the very end saying, therefore, the points on the curve are -2 and 0, -5 and -1 over 1,000, and 1 and 1/8, where the tangent line is horizontal.